Hello, my name is Edward Kim, and I am the group leader for Team 16 in Stats 160 with Professor Lingfei Kui. And now it is time for my final presentation of our weeks-long project of an analysis of the current job market. And this project was completed not just with using my skills, but also those of Kyle Fong, Roy Ho, Rachel Yim, and Lexi Chi.
Now, I will briefly walk through our project overview and explain how our system is structured from end to end. Our project analyzed the job market for students majoring in statistic-related fields across three states: California, New York, and Texas. We focus on six job categories, including software engineers, data analysts, business analysts, data scientists, machine learning engineers, and product managers. We built a complete data pipeline and an interactive platform that takes data from collection all the way to user interaction and job recommendations. First, for data collection, we scraped approximately 9,000 to 10,000 job postings from Indeed using JobSpy library, which interface with Indeed's GraphQL API. The scraping procedure retrieves detailed information such as job titles, companies, locations, salary range, posting dates, and full job description for each posting across the three states and job categories. Next, the data processing. The raw job postings were automatically saved into CSV file. This dataset were then passed through a clean pipeline that removed HTML tags from description, normalized serial values into numeric format, and standardized column names from consistency. This transformation produced clean, structured datasets that were ready for analysis and visualization on our dashboard. For a dashboard system, we developed an interactive website using Flask under an MVC architecture, with the front end built using HTML, CSS, Bootstrap, and JavaScript. The Flask backend explored RESTful API endpoints that supply data into the front end. Using Plotly, we created interactive visualization, such as salary distribution histogram, scale frequency bar chart, and job posting trend time series. Finally, we added a recommendation feature to support user interaction. Users can upload a resume in either PDF or text format, which is then analyzed and compared with the scrapped job postings. The recommendation system combines TF-IDF similarity between resumes and job descriptions, also have skill overlap matching and an experience score based on estimated years of experience. These factors are normalized and combined into a weighted ranking that returns the highest matching job postings for each user.
All of us, and probably you, are statistics majors nearing graduation and are likely curious about your prospects in this current job market. Many of us students are constantly browsing job searching websites like Indeed.com, and we wanted to figure out how to improve on this site and allow users to access more data of interest on its job postings. Specifically, we looked at six stats related job categories across three states and used a variety of modules and APIs in Python. We web scraped key features of these postings from salary range to skills required. These were later used to create the interactive recommendation model, which will be discussed along with the processes that allow to do everything else later in this presentation.
So today I'm going to show how we use JobsPy to scrape from 9,000 to 10,000 job postings from Indeed across California, New York, and Texas, and also walk through the technical challenges we overcame and also demonstrate the actual code that we decided to implement and also the data quality and results. So initially, we wanted to web scrape LinkedIn and Glassdoor, but we hit major roadblocks with the CAPTCHAs and IP bans. So after research, we basically found that JobsPy, an open source library, its interfaces with Indeed's GraphQL and API. and this solved a lot of our problems that we were having with LinkedIn and Glassdoor. So with Indeed, there was no blocking, and the structured data was really useful because the results that we gathered helped later on to implement into the website to display like all the information. And crucially, Indeed was had the most consistent salary information with 84% salary coverage compared to LinkedIn and Glassdoor, which only had like 30 to 40%. And a lot of the data was missing, such as sometimes skills that was required for the job postings. And then sometimes there wasn't enough information on the specific um, job that we wanted. For example, for research analysts, sometimes LinkedIn would only come up with 200 job postings when we initially wanted 500. So this is the scraping function in action. So first we import JobsPy and configure parameters like location and job count, and it returns structured data in seconds. So we imported like the location, we did California, New York, and Texas, and then like the search terms were the jobs that we wanted. So for example, this was business analyst, and we did data analyst and software engineering and so on and so on. And also the results wanted, we did 500, but this was really useful because you could increase or decrease the amount of data that we wanted. And because Indeed was so consistent with the amount of data that it was giving us, um, this format was really helpful for taking in the information. And the key is enforced annual salary equals true, which normalizes all salaries to yearly amounts. So as I run this and as we implemented it into a CSV file later on, 500 jobs scraped would be put into like a CSV file with salary, skills, company info, and everything. And so we basically repeated this for like the 6 other job categories across the 3 states in our notebook. And the scale achieved with this code was very efficient. We were able to gather 9 to 10,000 job postings across the 6 categories in 3 states. And most importantly, we achieved the like 80% or more average salary coverage. So that's doubled what we get from other resources. And we'd also were able to capture 25 data fields for each job, including full descriptions for the NLP analysis. And also, we were able to do this through no captchas, no blocks, and no failures. So this data quality was really crucial in the beginning for the analysis that we need later on into our project.
So this slide summarizes our data cleaning process for the CSV job dataset. First, we loaded our scale list from the scale JSON file, which served as a keyword dictionary for identifying technical skills inside job descriptions. Next, we organized our workflow by separating the data into raw and processed folders. All original CSV files collected from JobsPy were kept unchanged in the raw folder, while the cleaning version were saved into the processed folder for analysis. Then we performed HTML stripping and general text cleaning. Many job description has contained HTML tags, format symbols, and duplicate records, so we removed those elements to produce clean and readable text data. After that, we standardized salary formats by converting salary ranges into numeric values, which allows us to run consistent salary comparisons across different postings. We also use space scales to scan job descriptions and automatically match keywords from our skills list, helping us extract the technical skills mentioned in each posting. Finally, we removed irrelevant columns that did not contribute useful analytical information, which help reduce noise and keep our dataset focused on meaningful features for modeling and visualization.
Moving forward is our recommendation model. So first, we started by loading all of our processed job data, and this included every job posting, which was cleaned from California, New York, and Texas. We combined the CSVs, removed the duplicates, and prepared a single data set for the model to use. We then extracted resume information. So we allowed users to upload the resume in either a plain text file or a PDF file, and we extracted all of the text from it. And from this text, we pulled out two key pieces of information. One was their estimated years of experience, and two was their technical skills, using our skills.json dictionary to detect relevant skills that were mentioned in their resume. Next, we converted every job posting into text features by combining the job title, the job's extracted skills, and the full description. We used a TF-IDF vectorizer, which measures how important certain words and phrases are across the dataset. We then transformed the user's resume the same way and computed cosine similarity between the resume and each job posting. And to avoid inflated matches from longer job descriptions, we normalize these similarity scores to a 0 to 1 scale because in our original model, we were getting inflated job matches because of these long descriptions. And so we had to normalize it. Alongside text similarity, we also calculated a skill overlap score, and this measures how many of the resume skills also appear in a job skill list. And the score also ranges from 0 to 1, and we keep track of exactly which skills match so we can display them to the user. And lastly, we extracted the required years of experience from each job posting's description. We then calculated how close that requirement is to the user's experience. The jobs that are a better fit get a small experience bonus, which helps steer the recommendations towards more reasonable matches. And for our final scoring, we combined all three components into one overall ranking score, and the weights were 55% from the TF-IDF similarity, 35% from the skill overlap, and 10% from experience fit. And this weighted scoring system kept the recommendations balanced and prevented really any one metric from overpowering the others, which was actually an issue that we had with the previous versions of our model. And once every job had its final score, we sorted the results and returned the top matches. So, for example, you can see here, I uploaded my own personal resume, and you can see that two of the top recommended jobs were a data science intern and a machine learning engineer. Like I said before, we had problems with inflated job recommendations, which is why we incorporated our weighted system. Before, we were only using a TF-IDF similarity, but we decided to incorporate our weighted system, of course, so that the recommendations would be a lot more accurate. But with that, that was our recommendation model.
My main responsibility was designing the front end and API architecture, bridging between our raw data and the user experience. The goal was simple: ensure efficient data loading so that a user gets instant feedback without ever needing to reload the page. Coming back to what Lexi said earlier, as you can see on the left, our clean data sits in a folder of processed CSV files separated by state and job role. However, reading these files from the disk every single time a user makes a request would be incredibly slow. So I built a data loader module that merges these state-specific CSVs into a global data frame. This leads us to our most important backend optimization. We implemented server-side caching. You can see here in the code, we check if the all states data variable is already loaded. And if it is, we return it immediately. This means the heavy lifting of reading files happens only once when the server starts. Every subsequent user request is served instantly from memory. That data feeds into our Flask backend. A major challenge we faced was handling job titles. If a user searched for software engineer, we don't just want an exact string match. I used regex filtering here. This acts as an umbrella search, so a query for software engineer automatically captures related roles like backend, full stack, or DevOps. This makes the tool much smarter than a basic keyword search. Moving to the front end, we kept the tech stack lightweight using just HTML, CSS, and JavaScript. We used a modular design. You can see that every HTML page in our templates folder corresponds to a specific route in app.py. Each page provides a specific container ID, allowing our central JavaScript file to detect which page is active and load only the necessary charts. That central logic lives in main.js. It handles the API fetching and the visualization. We have a getData abstraction here that handles the async fetch requests. And down here, functions like loadSalaryChart take that JSON data and render it directly into Plotly histograms. One of the most critical user experience features we implemented was debouncing. Without debouncing, if a user wants to type Java, the browser would fire a request for J, and then JA, and then JAV, and then finally Java. This floods the server with 4 requests for just one search. With our optimized approach, we wait for a 300 millisecond idle period. This ensures we send just one API request once the user finishes typing, which drastically reduces server load. For our website, we use this so that if a user were to change multiple dropdowns in rapid succession, our application would wait for 300 milliseconds before making the API request to redraw the charts, preventing unnecessary server load. So to put it all together, here's how the user interaction would look. The user would first select California and software engineer. Main.js then sends the request with those parameters. Flask runs the regex filtering and computes the stats. The API then returns a JSON, and then Plotly finally re-renders the chart instantly. This architecture ensures our tool is scalable, fast, and responsive.
Now for the website demonstration. So if you click on this link wherever it's posted, it'll first take you to our homepage, on which you can click on these buttons or these tabs to navigate to the various different pages of our website. So for example, if you just want a summary or basically a repeat of what was in the presentation video, you can retrace our steps. And of course, if you want to look at our data, you can look at either our salaries, skills, or trends. So, and of course, look at different jobs in different locations. So, for example, you can see in California, for example, data scientists tend to overwhelmingly make between 175K and 225K. Same with skills. Well, skill sets, of course, are different variables, but you can see communication is one of the most demanded skills overall, but for different jobs like software engineer, Python might be more requested. And if you want to see when these jobs are posted, not just where and what they ask for, here they are. And for most of these jobs, as we said earlier, within the past month. And last but certainly not least, you can look at the recommendation model, which is the interactive component of this website. Now, a full disclaimer, this part tends to be a bit slow, so I wouldn't be able to upload my resume right now and put it in like a 2-minute long video. But for a sample of my resume, I have all of my skills listed as well as my projects. And using certain algorithms, our website is able to take in the text that is on this and recommend me a sample of 5 postings that it thinks I should apply to based on my skills. And of course, it's not perfect as we can see here, but oftentimes with our other resumes, for example, it would score about 75 to 80%. So that's part of our trial and error process of learning.